Newton first discovered calculus, he used limits without a rigorous definition. However, his results worked fine in applied sciences, so he never bothered to rigorize the limit. We currently understand limits as the value, as x approaches a certain value. However, the word approaches is not mathematically rigorous. Bolzano and Cauchy in the 19th century developed the Epsilon-Delta definition of a limit, the first rigorous definition of a limit. This is the formal statement of the Epsilon-Delta definition of a limit. But let's break it down. What does this actually signify? Function fx has a limit L as x tends towards a if for every epsilon greater than 0 there exists delta greater than 0 such that these inequalities hold. Let's consider this visually on a graph with the same conditions as before. Firstly, the inequalities indicate a belt created in the neighborhood of the value x approaches with the width of 2 epsilon and 2 delta. We define the limit L to be a value such that for any given positive value of epsilon and delta, the point AL exists within the belt created by the two values. This obviously does not apply in jump discontinuities, as in this case, there would be an infinite number of L's that can be applied within the belts of epsilons. Hence, as we already know, there is no limit for a point at a jump discontinuity.